Welcome back to The Explainer. Today we are jumping straight into a thought experiment that is just absolutely wild. It pushes the very limits of physics, math, and honestly our own imagination. We're going to see what happens if we could build a spacecraft that doesn't just travel fast, but exponentially accelerates by doubling the speed of light every single second. It's the ultimate cosmic road trip, and I can't wait to walk you through exactly how this math plays out. Okay, so imagine a highly advanced, hypothetical ship. We're talking something built by a Type 3 or Type 4 civilization way in the future. Now, this isn't just any ship. It operates with perfect calculation, consuming raw, galactic, exotic matter to fuel its exponential acceleration. It starts right at the speed of light, and then, tick, 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 every single second that passes, its speed doubles. So where exactly would we go? And how far could we actually get? Let's start the clock. Section 1, the exponential space journey, starting the engine. Right, before we slam on the gas pedal, let's just ground ourselves in the sheer, incomprehensible scale of the cosmos we're dealing with here. To really get this, look at the contrast. Our Milky Way galaxy is roughly 94.6 million billion kilometers across. At the normal speed of light, which is about 300,000 kilometers per second, it would take a painfully sluggish 100,000 years just to cross our own galaxy. I mean, on a cosmic scale, normal light speed is practically a snail's pace. It is totally restricted by physical limits. But with our exponential engine, yeah, we're definitely not going to be waiting around for 100 millennia. Section 2, escaping the solar system, 0 to Oort cloud. Okay. Strap in. We're starting the clock now, and you're going to watch our familiar, cozy solar system completely blur past us in mere seconds. So just 1 second in, we cover 300,000 kilometers, leaving the moon in our rearview mirror. By second 3, we're doing 1.2 million kilometers a second. Now watch what happens at the 10-second mark. We blow past Mars, 220 million kilometers away, traveling at 1,000 times the speed of light. At 15 seconds, we cross Pluto so fast it's completely invisible to the naked eye. And by second 26, we blast right through the Oort cloud, the final boundary of our solar system. At this exact moment, we are traveling at 67 million times the speed of light, literally covering 2 whole light years every second. Section 3, crossing the Milky Way, interstellar travel. Moving right along, we've officially escaped our stellar neighborhood in under half a minute. Let's see what happens as we hit deep interstellar space. You see, the exponential math here makes interstellar distances practically meaningless. At second 27, we fly past our neighboring star system, Proxima Centauri. By 30 seconds, we've only covered 34 light years, which, might sound kind of slow for a galaxy that's 100,000 light years wide. But remember that exponential curve. Just 1 second later, at 31 seconds, we've jumped to 68 light years. By 39.5 seconds, we are tearing right past Sagittarius A star, that supermassive black hole at the center of the Milky Way. And at exactly 41 seconds, we hit the very edge of our entire galaxy. Now pay close attention to what happens right at this 41-second mark. As we exit the Milky Way, our spaceship's engine runs out of the galactic exotic matter it was using to fuel its exponential growth. So our speed locks in. This becomes our terminal velocity, a staggering 70,000 light years covered every single second. Just to put that into perspective for you, we are now cruising at 2.2 trillion times the speed of light. It's almost hard to wrap your head around, right? Section 4, beyond the observable universe, intergalactic space. Okay, with our speed firmly locked at 70,000 light years per second, we are zooming out from local stars to the absolute vastness of intergalactic space. This part brilliantly illustrates the nesting doll structure of the cosmos. Within 2.5 minutes of leaving Earth, we cross the local group, flying past 80 distinct galaxies. In 26 minutes, we traverse the entire Virgo supercluster, a structure 110 million light-years wide. And in just 2 hours and 4 minutes, literally the time it takes to sit down and watch a standard movie, we completely cross the massive Laniakea supercluster, spanning 520 million light-years. We've officially left behind every single structure our Milky Way is connected to. Let's really anchor our sense of time here, because this is where the mind starts to boggle. Remember the Andromeda Galaxy? We reached that in just 1 minute and 17 seconds, total mission time. Now, if we keep flying at our locked speed, we cross the entire 93 billion light-year expanse of the observable universe in exactly 15 days and 10 hours. Just think about that. 15 days ago, we were sitting back on Earth. Now we have traversed literally everything humanity can currently observe. We've actually beaten the expansion of the visible universe. But the universe we can see isn't the whole story, is it? Watch how this builds when we consider the theoretical unobservable universe. Some scientists estimate the universe's lower limit is 250 times bigger than what we can see, right around 23 trillion light-years. At our speed, crossing that takes 10 years and 7 months. If the universe is 100,000 trillion light-years across, that's a 45.5-year journey. And if it's a staggering 154 trillion light-years, over 10,000 times larger than our observable bubble, it would take an entire human lifetime, 70 long years, zooming at 70,000 light-years a second just to cross it. The source material uses a really fantastic analogy here to ground this incomprehensible scale. Imagine you're walking. Crossing our tiny observable universe in 15 days is like taking 15 days to walk past our sun. But trying to cross the true theoretical universe in 70 years, that is the exact equivalent of trying to walk past Stephenson 218, one of the most gargantuan stars ever discovered. The sheer difference in scale is completely humbling. Section 5. The universe always wins. The final limit. And here we are, at the ultimate twist in our explainer today. We've been on this incredible, infinite, cosmic road trip, feeling pretty invincible. But eventually, we hit a wall. To understand exactly why, we have to talk about dark energy and the Hubble constant. Think of this as a giant cosmic treadmill effect. The very fabric of space is constantly being stretched and pushed apart by dark energy. Even outside our observable universe, this expansion is happening everywhere, all at once. And because space itself is expanding, the literal distances between points are growing. So what's the exact mathematical defeat point? It's 3 times 10 to the 22nd power light years. That's a distance 333 billion times the size of our entire observable universe. When we reach this incredibly distant coordinate, the cumulative expansion of space across that vast distance finally becomes faster than our locked terminal velocity. Suddenly, even at 70,000 light years a second, we can't even reach the next star. The cosmic treadmill is moving backward faster than our running forward. Which brings us to a final, pretty awe-inspiring realization. Even if we could build a ship that doubles the speed of light every single second, even if we conquer galaxies in seconds and the observable universe in a couple of weeks, the true universe eventually outpaces us. It defeats even exponential growth. It really makes you wonder, if a ship traveling 2.2 trillion times the speed of light eventually loses to the sheer expansion of reality, just how truly infinite is the cosmos? That is something to chew on. Thank you so much for joining me on this incredible journey today. Keep wondering, keep learning, and I'll see you in the next explainer.